Okay, welcome back to part 2 of our chapter 5 lecture, forensics and physical evidence. And we've got a lot of ground to cover, so we're just going to jump right back in. So we left off, or we finished up, we talked a little bit about chain of custody and marking, identifying, collecting evidence. And I believe we talked about packaging and transporting. And then we looked at how to store it and looked at a couple of property rooms to show you what a good property room looks like and what a bad property room looks like. So now we're going to talk about evidence in court. So evidence is of little value to a criminal case if it is inadmissible in court, right? So to ensure admissibility, we really need to adhere to a strict protocol because, again, that's going to be essential to ensure that our evidence may be used during trial. Now, typically the officer who will identify the evidence in court obtains it from the evidence custodian and delivers it to the prosecuting attorney, who takes it to the courtroom and it's introduced at its proper time. Now, the identifying officer also uses the notes that he or she made at the scene to lay the foundation for actually identifying the evidence in court, because you're going to have to identify it in court. So to ensure this admissibility, you need to first, number one, identify the evidence as it is found at the scene. And you're going to be asked to identify it. Officer Smith, can you identify this? And then you're going to have to be able to describe exactly where it was found. And how would you do that? It might be listed in your report, or even in a sketch or a diagram, but either way, describe where it was found. You're going to need to establish its custody, meaning who found it, and how did it get from the crime scene to court today. And then finally, you're going to have to be able to voluntarily explain any changes that occurred. So if a piece of evidence was accidentally broken or ran over or whatever, or moved, let's say it started to rain and you had to move something, you're going to have to voluntarily explain why there were some changes and why something had to be removed or picked up, etc. But to ensure admissibility, you're going to have to be able to establish these 4 points. And again, when you talk about identification, again, it might just be a firearm. And like in this picture right here, this officer is testing about the firearm used in the George Zimmerman case. Now, how would he be able to identify it? It could be by a property tag that was put on there. It could be by his initials that were put on a tag and then wrapped around the trigger guard. It could be by the serial number that's on the firearm, and then it was placed inside of an envelope, and on the outside of the envelope it had the serial number, and they match them up together in court. But either way, you're going to have to be able to identify the firearm. Okay, same with this particular case here. And if you want to see a pretty decent example of officer testimony on identifying a firearm, there's a short video of this officer that testifies about an individual that tried to run him over with his patrol car. Yes, he stole his patrol car, and the officer used lethal force. And in this trial, he is identifying, he's laying the foundation for getting his evidence admitted by making sure that these 4 points are established. That's how you lay the foundation, and hopefully that makes sense. So what do we do then after everything's done? So when we talk about our final dispo of evidence, where does it go? Well, evidence must be legally disposed of to prevent major storage issues, as well as theft or unauthorized conversion by personal use. So state statutes and city ordinances usually specify how to dispose of evidence, but most do not really specify when. They might tell you how, but not when. Therefore, departments typically go by the statute of limitation for the type of case when deciding how long to hold items of evidence before disposing them. Now, every criminal offense has a statute of limitation, except homicide. And these statutes, again, vary from state to state. So sometimes you're going to have to hang on to evidence for a long time. But typically after a case is closed, a couple of things might happen. Evidence must be legally disposed of. So one way would be returned to the owner if it's stolen property. Next, it could be auctioned off. Let's say you have a bunch of stolen bicycles with no serial numbers. So there's no way to prove who the owner is, so you may be able to auction that off. And then finally, evidence might be destroyed. And here you have a photograph of a couple of police chiefs, and I think I'm in the picture. Yeah, here I am, kind of the short, bald guy right here. And every year we would have what is known as a gun burn. And all these illegal firearms that were not stolen that we could return, and the cases were adjudicated from all of these different, these are all different agencies. So it's not just Rialto, it's other agencies that are with me as well. So we have 6 different agencies besides Rialto. But anyway, we would take them to a metal factory in the city of Fontana, and they would melt them down. And that would be the proper way to destroy them. And then we would keep a receipt showing that these different weapons were properly destroyed. And hopefully that makes sense. So that's one application of how evidence must be legally disposed of. I have a video that if you want to take the time to watch it, that kind of shows all the different aspects of forensics labs, because we're going to start to talk about frequently examined evidence and the different types. And each lab usually has like a special area for fingerprints or for firearms and ballistics, etc. So it's a pretty good video. But let's talk a little bit about fingerprints. So since Francis Galton's published his classic textbook called Fingerprints back in 1852, I know it's a long time ago, and Sir Edward Henry developed a system to classify fingerprints in 1897, called the Henry system, by the way, it could be argued that the science of fingerprinting remains the single most important discovery in criminal justice. Really, only DNA rivals the fingerprint as an absolute method of proving a person's identification. And at the end of each human finger, on the palm side, exists a very unique arrangement of small lines. And these little small lines are called friction ridges. And these provide just enough, roughness to give fingers traction when holding or otherwise manipulating objects. And with these friction ridges, or within these ridges, would lie like sweat pores. And when the sweat they produce mixes with your body oils or dirt or other matter, that substance will rub off on any surface that the finger touches, leaving behind a print if the surface is relatively smooth. Now, these prints are useful in criminal investigations because a person's friction ridge patterns are formed before birth and remain the same throughout that person's life. And although many lay people assume that identifiable fingerprints are almost always found at a crime scene, the reality is that in many cases there are no prints found. And even when there are, it's often difficult to locate the person who matches the prints that are found. So, when you look at it in its entirety, again, frequently examined physical evidence is going to include fingerprints and voice prints and language prints and DNA and blood and body fluids and hair and fibers and shoe and tire impressions and bite marks and tools. And we're going to look at a lot of these, but we're not going to be able to get through each one. But let's talk briefly about fingerprints. So fingerprints are of various types. They are latent, visible, or plastic. Now, latent fingerprints are impressions transferred to a surface either by sweat on those ridges that I talked about of the fingers, or because the fingers carry residue of oil or dirt or blood or some other substance. And latent prints are not readily seen, which is why they call them latent, meaning kind of invisible. But they can be developed by using powder or chemicals. And typically, they're normally left on smooth, non-porous surfaces. Now, visible fingerprints are made when fingers are dirty or stained. They occur primarily on glossy or light-colored surfaces, and they can also be dusted and lifted. But you can see them. And then finally, plastic fingerprints, is a form of a visible print, but it's more like impressions that are left in, let's say, a soft substance like putty or grease or tar or butter or even soap. And these types of prints are typically photographed, not dusted. And any hard, smooth, non-porous surface can contain latent fingerprints. So when we look at these, when you look at this would be a latent fingerprint on a glass that was dusted with black powder. And then you would, after you put the powder on, and I'll explain a little bit how to dust for prints, and then after you brush the powder on, you would take a piece of tape, put it over there, you would pull the print off and put it on a backing, and that's, you would see the print like that. And then you can even photograph them afterwards. This would be an example of what we called a visible print, where maybe you touch something, whether it's paint or here blood, and then you touched another light colored surface and you can see the print because it's visible, it's not latent. And then finally, a plastic print where you would have an impression of the ridges, the friction ridges on your finger. That would be an impression. And a lot of times, don't forget tape, because if somebody would use, let's say, like duct tape to wrap somebody up or to bind somebody, a lot of times you can find those impression prints or even a visible print on the back of the tape where they touched it because it's really, really sticky. So hopefully that kind of makes sense. So how do you dust for prints? Now, I don't have time to give you the whole lesson, but we'll give you just a couple of quick examples. So you're going to begin the search for fingerprints by determining the entry and exit points and the route through a crime scene, because that's going to be important. How did they get in? How did they leave? And how does it look like they walked through the location? Look in obvious places as well as the less obvious places, as the underside of a toilet seat, the back of a car rear view mirror. Examine objects that appear to have been moved, like little knickknacks or something. You may need to expose surfaces to light at a different angle. So taking your flashlight and kind of putting it at an angle to see the print there. It may even be in dust. You might be able to see the print in some dust. Consider the nature of the crime and how it was probably committed. Now, prints found on large immovable objects are typically processed at the scene by photographing and dusting with powder or chemicals, etc. But otherwise, you can take the object to the station. But dusting for prints. So fingerprint dusting powders are available in different colors, and you'll see why, and chemical compositions to provide maximum development and contrast, because you need the contrast to see the print. When dusting for prints, use a powder that can contrast in color to the surface. So if you have a white car, like in the photo, you might want to use black powder. And do not use a powder unless it's necessary. Do not powder a print unless necessary, and do not powder a visible print until you photographed it. But anyway, the number one mistake that officers make is over-processing the latent fingerprint. So the first rule is use less print powder than you think, because it really goes a long way. And another serious error would be the forensic integrity and value of the print in using a contaminated brush. So you're going to want to have a clean brush. So clean brush, wear gloves, apply the powder to the brush lightly, and you're going to spin the brush in your hand to kind of swirl it. Sometimes you can go from side to side, but typically you're going to swirl that brush, and you're going to do that by putting the brush between your hands and making it go back and forth, if that makes sense, until you start to see the print. And then you're going to remove the excess powder, which you could do by actually blowing on the print if you wanted to. And you're going to want to photograph it if you have a camera that you can take close-up photos. And that's really important. And you can find more on page 151 on how to actually dust for prints. Now, when you're going to lift it, to lift fingerprints, you're going to want to use a commercially prepared lifter that has both a black and white background and a wide transparent lift tape. You don't want a skinny piece of tape, you want a fatty piece of tape, right? And your background that you're going to put the tape on with the print, you want it either white or black because you want it to contrast. Does that kind of make sense? So typically, again, use black lifters for light powders and light lifters for black powders. And to lift a print on a doorknob or a rounded surface, use transparent tape so you can see where the print is and any spots where the tape is not sticking. Put the tape over the dusted print. Don't use too much pressure. Work out just very slowly any bubbles that kind of appear by applying a little extra pressure. And then lift the print slowly. And after you've lifted the print, you transfer it to a fingerprint card. Now, common errors in lifting prints include removing too much or too little powder from the ridges, allowing bubbles again to develop under the tape, and then failing to make two lifts when a second lift would be better than the first. So you can actually dust a print twice or take a lift twice. But here you can see that you're just, even on a sort of a round object here, you can still use the tape and you can lift that print right off. And page 152 talks a little bit more, 151 and 152 talk a little bit more about fingerprints. And remember, I told you there's different color powders. There's regular black powder, and it depends what color you want. They even have fluorescent powders because you might want a print to look like this to be easy to photograph. Or sometimes even yellow, sometimes green, which is super cool, right? So you have all these different colors that you can use. But what are some other ways besides powder to deal with prints? Well, there are ways to chemically develop prints. So although powders are used to develop latent prints on many surfaces, they are not really recommended for unpainted wood or paper or cardboard or any other absorbent surface. So powder's good on those non-porous type things. So using powder on all surfaces will smudge any prints or destroy their value as evidence. And for such surfaces, you may want to use a special chemical, things like iodine or ninhydrin or silver nitrate, or even super glue. So the iodine method takes iodine crystals and they're placed in a fuming cabinet or a specially prepared fuming gun, and the crystals are heated and vaporized, producing a kind of a violet fume that is absorbed by the oil in the fingerprints. And the fingerprint ridges will then appear kind of yellowish brown. And with that, after that, they're going to need to be photographed immediately because then they'll kind of fade. So fuming cabinets and guns can be made or purchased from, police supply houses, etc. The ninhydrin method develops the amino acids in the print. So ninhydrin, which is also really flammable, so you have to be careful, is available in spray cans or in a powder form, from which a solution of the powder and acetone or ethyl alcohol is made. Now you can see why it's flammable. And the evidence is then either sprayed or brushed or dipped into the ninhydrin. And development of prints can be speeded up by applying a little bit of heat, let's say from a fan or an iron or even an oven. But again, you have to be careful. And they kind of develop really quick. The other good thing is that ninhydrin developed prints, they don't fade immediately, but they will eventually lose the contrast. So you really need to do the same thing and photograph them as soon as possible after development. Then you have silver nitrate development, and this is where you take sodium chloride in the fingerprint ridges into silver chloride that appears as a kind of a red-brown print. And because silver nitrate destroys oils and amino acids, it must be used after the iodine and the ninhydrin methods. So you're going to immerse the specimen in a solution of silver nitrate and distilled water. You're going to remove it really quickly. You're going to hang it to dry, and then the prints will start to develop. And you can even apply a little bit of light to help them develop a little bit more clearly or quickly. And they too need to be photographed immediately because they will disappear after several hours. And then finally, a very, very common method would be super glue. So fingerprints may also be located and developed using a MagnaBrush technology, laser technology, gelatin filters, and super glue. And this is actually one of the easier ways to do it. So super glue fuming involves heating 3 or 4 drops of glue in a chamber to generate fumes that actually stick to the fingerprint. And this process can effectively develop prints on things like plastic or blank checks or counterfeit money or metal or even skin. And portable lasers are also used to find and highlight fingerprints. And they can detect fingerprints on the skin of a murder victim and even trace the path of a gunshot. So a lot of different types that you can use. And here you have the ninhydrin solution that I talked about, and we use that for paper a lot of times. Here would be a fuming chamber. Super glue, again, is kind of ones that we take. Here's a firearm that's been super glued. And what happens is these ridges will stay. That glue, they'll start to crystallize and stay, and you can photograph them, and then you can even dust them when you super glue. So you have a bunch of different options. And then don't forget, we still have the other method of fingerprints. And what I'm going to talk about now is something called examination prints. So if fingerprint evidence is found at the scene, it is important to know whose prints belong at the scene. And those are called elimination prints. And typically we will do this by way of ink prints, which is kind of rolling your fingers. And most of police departments have equipment for taking fingerprints. And the standard procedure is to basically fingerprint all adults who have been arrested, either at the time of booking or at the time of release, or again, we'll take these elimination prints. So if my house were to get broken into and they found some fingerprints, they would take my fingerprints, because those would be elimination prints, and then if any different ones were found, then that could be the suspect. But it's important to have these elimination prints, and hopefully that makes sense. We also have, some cool stuff now. We have digital fingerprinting. And, this has, for the most part, replaced those inked prints where you kind of roll them. Have you ever had a live scan? Some places where if you're going to get employed, like a teacher, a nurse, police, you're going to get a thing called a live scan. And they're not going to do the old rolled prints. They're going to do these digital fingerprinting things. So here, your latent prints are scanned and converted into a electronic image. And it's kind of called a inkless fingerprint. And they can be blown up as well. And here you can see if they were to be evaluated, you can actually blow them up into a bigger print where you can look at them and you can look at the ridges. So that's another benefit of these, digital fingerprints. Now, once a fingerprint has been captured, whether chemically developed, rolled in ink, or digitally scanned, whatever it is, the fingerprint patterns need to be analyzed for unique features that we hope will lead to a suspect. And fingerprint patterns are classified basically, okay, this is basic, as arched, looped, or whorled. Now, variations of these configurations result in 9 basic fingerprint patterns, and you can find those on page 155. But here's kind of what some of them look like. Okay, so you have a plain arch, a tented arch, a plain loop, you have the whorl, you have the central pocket loop, you have the lateral pocket loop, a twinned loop, and an accidental. So you have all these different types of characteristics, if you will. Now, when it comes to examining fingerprints, there are as many as 150 ridge characteristics in the average fingerprint. Now, examiners, if they want to match a print, they need to match a minimum of 12 to 20 points on a single finger for a positive ID. So if they're comparing these two prints, they need 20 identical matches in order to make this a match. Typically 12 to 20. More is always better. But again, that's what you would need to match. And because, remember, because of the computer, you can actually, we have people that still do this by using their eyes, and they're very good at fingerprint analysis, but computers really do help in the analysis of fingerprinting. And here's kind of a bigger picture, because this is what you could do as a fingerprint individual. And you can see, so if we look at this one little ending right here, and then we go across, that would be this right here. So sometimes it takes a little bit of a special eye to kind of see that, but that's how they're going to match up a fingerprint. Okay, so what would be the usefulness of prints? And there is some usefulness. Well, fingerprints are positive evidence of a person's identity, right? Because typically it's only one person matches to that fingerprint. But what can they not do? What are some things that fingerprints maybe that they can't do? It's just kind of interesting to think about that. Well, think about it. What can they not? Can a fingerprint show gender? Can a fingerprint show age? Can a fingerprint show race? Can a fingerprint show ethnicity? So you have to kind of think about it. And the answer is going to be no, but it can show identity, which is good. Now, DNA, on the other hand, and we'll talk about that in a minute, will be able to show a lot more. Okay, so we talked a little bit about usefulness and things like that, but what about admissibility in court? Because at the end of the day, after we do all this stuff, we're going to take this stuff to court. So to ensure admissibility in court, investigators should establish what we call the probative value of the print. That is, the defendant had claimed never being at the scene. So think about that. It's the important probative value means that it lends itself to the investigation. It has value as far as the improving guilt or innocence. So if somebody says they've never been at this place and you find their fingerprint there, is that probative value? Absolutely, because they said they were never there, but yet you have a print that shows that they were there. Does that help establish guilt? The answer is going to be yes. It's not a bad idea to understand and look up what the word probative means. And a couple of other things quickly before we run into DNA. In 2006, the FBI and the Department of Homeland Security, they merged their fingerprint databases into one, which is known as the Integrated Automated Fingerprint Identification System, called IAFIS. It used to just be called AFIS, but now we have a lot more accessibility and prints. And the IAFIS provides automated fingerprint search capabilities, latent searching capabilities, electronic image storing, and electronic exchange of fingerprints and responses 24 hours a day, 365 days a year, so all the time. And as a result of submitting fingerprints electronically, agencies receive electronic responses to criminal fingerprint submissions within about 2 hours, and within 24 hours for civil fingerprint submissions. So a very quick turnaround. Now, IAFIS maintains the largest biometric database in the world containing the fingerprints and corresponding criminal history information for more than 55 million people in the criminal master file. And the fingerprints and corresponding criminal history information are submitted voluntarily by state, local, and federal law enforcement agencies. Now, very quickly, what are some other types of prints? Because fingerprints are cool, but what about palm prints? They have ridges, and so do ruffles. I'm sorry, bad joke. Okay, but anyway, they have ridges, so we could use a palm print. How about a footprint? Those could be used, and they are used in certain types of investigations. How about a lip print? You're probably going, what? Yes, even lip prints can be compared and classified. So kind of an interesting thing, right? What about a voice print? So a voice print is a graphic record made by a sound spectrograph of the energy patterns emitted by speech. So that's the little lines that you see kind of going up and down. And like fingerprints, get this, no two voice prints are alike. And voice prints can assist in identifying people that call in bomb threats, obscene phone callers, and others who basically use communication devices illegally. So is that kind of cool? And the people that do this, you know, they deal with the linguistics and stuff like that. And a lot of times you might get what we call excited utterances, meaning that somebody may just spew out some phrase, and you're going to want to maybe compare that with other crimes where somebody has said the same thing. So voice prints, kind of a cool thing. Okay, so now we're going to jump into DNA, and we do have a lot to cover, so I'm hoping I can get through the rest of this. But human cells contain discrete packs of information known as chromosomes, which are made of DNA. Now, typically DNA is only used on violent crimes. However, it may also be used on high-volume property crimes, like a burglary, a series of high-profile burglaries or something like that. Now, investigators must be trained in the identification, collection, and preservation procedures, just like they were collecting regular evidence. So it's important that they are trained on that, because you don't want to mess that up, right? Now, again, DNA, it has a unique characteristic, and it's basically referred to as a genetic code. And this code in DNA can be used to create what we call a genetic fingerprint to positively identify a person, with one little exception: identical twins. Sometimes identical twins will have very similar DNA structure, or even the same DNA structure. But other than that, everybody has their own DNA fingerprint. Now, again, DNA profiling can be done on cells from almost any part of the body and is used in paternity testing, immigration disputes, missing persons, unidentified body cases, and criminal and assailant identification, right? Now, in the past, DNA evidence was usually, again, only used for like violent crimes. But, I think law enforcement has realized or is beginning to recognize the value of DNA technology to solve high volume property crimes, things like burglary, despite the cost. So because of the expense, and we're talking about DNA, human DNA profiling again, because of the expense and time involved, there really are 3 criteria that need to be met for a lab to accept a DNA sample. And the first is sufficient material, meaning you have to submit a sufficient amount of DNA material. And you really don't need that much. Number 2, samples must be submitted from both the suspect and the victim. And then number 3, the evidence must be probative. And did you look that word up? Meaning it's going to show guilt or innocence. It's going to be linked to that crime. So it has to be probative. So those are the 3 criteria. And if you've never seen a DNA sample, well, here's what one looks like. So on the left, you have, let's say this DNA was processed. So we processed this DNA, and here's the fingerprint, this skinny line. And here are 3 potential suspects. And then all you really do is you can kind of match them up and figure out, look, suspect 2 appears to have the same DNA profile, the same pattern, right? So this guy would be your suspect. Sometimes, depending upon the type of DNA testing, your fingerprint is going to look a little more like this. Here's a fingerprint that we actually did. Thank you very much to our biology department, especially Professor Nick Reeves, who sometimes will allow us to come into his classroom, and he will put on a couple-hour DNA processing lab. So again, thanks, Nick, for all of your help. But this is what it looks like. We'll process the DNA in the classroom, and we'll get this profile. You'll start to see the profile. So that's actually processing DNA. So again, kind of a cool thing. So thanks to Professor Reeves for that. It's actually kind of a really cool thing. So what about DNA databases? So in 1990, the FBI launched a project called CODIS, which blended forensic science and computer technology to help solve violent crimes. And it now contains over 500,000 profiles. And the convicted offender index contains over 10 million profiles. So a lot of information is being held in CODIS, which is actually pretty cool. So again, CODIS is a database that's organized into 2 indexes. So it has the forensic index and the offender index. Now the forensic index contains the DNA profiles from crime scene evidence where the offender's identity is unknown. The offender index contains the DNA profiles of individuals convicted of sex offenses or other violent crimes. Okay, so you have a couple of different indexes. Now, by September of 2013, again, it was estimated that the index contained a little over 500,000 profiles, and the convicted offender index contained over 10 million profiles. There's a really interesting case, and I put it in here for you to look at. I have a link to the case and then a link to a video on Maryland versus King that deals directly with DNA and the taking of DNA at the time of arrest. So what about other fluids? I mean, well, you know what? Maybe I should talk about really quick the exoneration. So I don't want to go too far, but let me back up a little bit and talk a little bit quickly about admissibility in court. So today, a DNA match is virtually indisputable in court, and DNA can identify a criminal with a near absolute certainty or exonerate a suspect. But keep in mind that the potential for human error and contamination is still a critical factor in determining DNA evidence and the admissibility of that evidence in court. Now, finally, DNA evidence is not only used, as we've said before, to convict people, it's being used to exonerate those wrongfully convicted. Now, data provided by the Innocence Project, which is a group founded by the, I think it's the Cardoso School of Law in New York, reveals that 325 people had been exonerated through DNA testing as of the time of this textbook writing, when this book went to print. And the leading cause of wrongful conviction, they found out, was misidentification. And I think we've talked about that, or we will talk about it when we talk a little bit about identification procedures, etc. Okay, so again, what about some other types of fluids? So blood is frequently analyzed for DNA, but it and other bodily fluids, things like semen, urine, like that, can also provide other valuable evidence to investigators. Blood, for example, assists in establishing that a violent crime was committed, in recreating the movements of a suspect or a victim, and in eliminating suspects, maybe the blood path, right, or the blood spatter. Body fluids can be found on a suspect or a victim's clothing, on the floor or the walls, or on furniture or on other object. And some body fluids, like semen or saliva, they may be difficult to detect, but given their fluorescent properties, they will become visible under a special light source, or if you add something to it. So specifically, you can use a black light source to see semen, but you could also use something called luminol in order to see blood, because it reacts with the iron in somebody's blood. So again, a number of reagents, chemicals, if you will, including things like luminol, can identify blood at a crime scene, and because crime laboratories are swamped with evidence to examine, this preliminary on-scene testing is really important. So for luminol, kind of an example, it's an easy-to-apply water-based solution. You spray it from a pump bottle over an area where you believe blood is going to be there. And luminol causes blood to kind of turn a color. It's a pale blue color. And again, it detects blood that has been diluted, even if it's been diluted like 10,000 times. You know, another benefit to using luminol is that it doesn't harm DNA. So that means that you can collect the blood for DNA analysis. You know, blood stains, we talked a little bit about that. That's the study of, you know, blood stain pattern analysis is the study of blood stains to assist in establishing the sequence of events that occurred, and sometimes after the act. So depending upon how the spatter, the direction it's in, the amount of drops, the pattern, you can tell. You can also use this to help you determine the amount of physical force. And with a sufficient quantity of bloodstain evidence, investigators can analyze the shape and distribution of these blood stains to determine the location of people or objects at a crime scene, maybe where they were killed at exactly, the movement of people or even other objects within the scene because they might touch something with their bloody hand, etc. So, I mean, a lot of blood is good for a lot of different things. So, you know, you look here, here's a photo of luminol where you can spray this and you can see the light blue that comes to light, and you can see footprints. You can see it on an individual's clothes. Here you have it in the bathtub. You can see when you look at blood spatter, you can see the direction, you know, if it's on the roof, whether it's on the walls, if you have a trail of it. If you have it pooled in one area, that means that the victim was at a certain spot for quite some time. If it's a big enough pool, you can draw the conclusion that that's where the victim was actually maybe stabbed and died in that place, in that exact position. So again, the blood pattern analysis can help determine where the blood originated, the distance from there to where the blood came to rest, the type and direction of impact creating those stains, the type of object maybe producing the spatter, and the position of the victim and the assailant during and after the attack. So a lot of good information. Okay, so what else do we have to look at? Well, how about scent? So you know, every person has a unique scent, and scent pads can be presented to tracking dogs in order to help, you know, maybe locate evidence. So a type of evidence that typically doesn't receive a lot of attention is this scent evidence, and every person has a unique scent, which really can't be masked or eliminated, not even by the most nasty perfume, if you will. And a person's scent profile is the combination of sweat, oils, and gases in their body. And these smells, along with skin cells everybody constantly sheds, because we do, believe it or not, are detectable to specially trained scent tracking dogs. And a lot of times we might use this for child abductions or something similar. So scent. Hairs and fibers are often difficult to locate without a very careful search and strong lighting. So light sources are commonly used to locate hair and fiber evidence in carpets or on bedding or other surfaces. And they are vulnerable evidence because they can place a suspect at a crime scene, especially violent crimes in which interchange of hairs and fibers is likely to occur. And the suspect can also take hairs and fibers from the scene unknowingly. Maybe, you know, or you might find it underneath a victim's fingernails. So again, you know, examining fibers, these fibers have a very unique characteristic. So we talked a little bit about, you know, hair and stuff like that, but, you know, fibers fall into 4 general groups: mineral, vegetable, animal, and synthetic. And they all have certain characteristics that can be analyzed chemically. So hairs and fibers are very, very important. Well, what about shoe prints? Well, this is another important one. This is very common evidence at a crime scene. And if collected, recorded, and analyzed properly, these shoe prints or even tire impressions can yield valuable investigative data. Now, after photographing these, you should cast these shoe or tire prints to get a, you know, and so here's what it looks like. So here you have a tire print in the mud, and they're getting ready to do a cast. So you would photograph it so you can blow it up, but then you're going to do a cast. And here's another tire print. Here's a shoe print. Now, do you think this would be important? What if you found the suspect wearing the same kind of shoe? So here's a bloody footprint. So again, this is important evidence. So these are things that you don't want to overlook. What about bite marks? So bite mark identification is based on the supposed individuality of teeth and it's legally admissible in court, having endured a number of legal challenges. So it's actually legal in court. And bites may occur during the commission of a violent crime inflicted by either the victim or the suspect. And the marks left behind can be collected as evidence. And bite marks may also be found in partially eaten food or other objects that have been placed inside of a person's mouth. And if the impression is visible, photograph it and then swab the bite area for saliva, blood, residue, DNA, and any other microorganisms. Then cast it in the same way as a shoe and a tire impression. Dental impression material is again preferred because of its fine texture. So you ever get braces and you had impressions made for your braces? It's the same thing as it relates to bite marks. And you can see that sometimes bite marks are serious. And you may want to photograph that because of the serious nature of the crime. And maybe be able to match them up. So I know these are extremely serious cases, but I wanted to really kind of get across to you the importance of that. So it would be the same with tool marks. So common tools are often used in crimes. So a tool mark is an impression that's left by a tool on a surface. So maybe a screwdriver by scraping or jamming it into this door frame here. So you're going to want to photograph the tool marks, and if you can, cast them or send the object. Oh, got a little typo there. Send the object of which they appear, to the lab. So you could actually, instead of cutting the door out or the door frame, you would unscrew these two screws right here, and you could take this plate and you could send that plate to the lab. So just like bite marks, tool marks is a real important item of evidence. Because again, a tool mark is that impression that's left by a tool on a surface. And it can be matched up. These are things that you can match. The same with firearms. Many violent crimes are committed with firearms, and each firearm imparts a distinctive fingerprint, or what we call a ballistic signature, to every bullet that's fired through it, which provides us with useful evidence to work our case. Now, the broad definition of ballistics, you probably heard that phrase before, is the study of the dynamics of projectiles. So just to kind of give you a little bit more, the bore refers to the inside portion of a weapon's barrel, which is surrounded by raised ridges called lands and recessed areas called grooves, thus the term lands and grooves. And these lands and grooves comprise what we call the rifling, the spiral pattern cut down the entire length of the firearm barrel that basically grips and spins the bullet as it passes through the bore, providing greater control and accuracy. Does that make sense? And the caliber refers to the diameter of the bore as it's measured between the lands as well as the size of the bullet. And hopefully that kind of makes sense. And on page 173 is a diagram, but I think we kind of covered it. Now, one thing that you'll see as an investigator, especially under a microscope, is what we call striations. So again, and so as this bullet rotates through the barrel, it receives highly individualized characteristics or marks or scratches or striations, which is actually the word I'm looking for, from the rifling, which are going to provide valuable comparison evidence on recovered bullets. So a fired bullet is marked only by the barrel, but a fired cartridge case is marked by several parts of the weapon when it's located, fired, and extracted. So here we're going to use a comparison microscope, and we're going to compare these two bullets with the striations. And we're going to match them. And look at how they match up, especially in the big areas. And even in the little ones. Would you say that these two were fired from the same weapon? The answer would be yes. So that's how investigators look at firearm evidence. So again, I kind of went through the issues on the bore. I kind of got a little ahead of myself, but we've already covered that. Another piece of evidence that's important is something called gunshot residue. This is another type of evidence that investigators might seek in solving firearm crimes, because whenever a firearm is discharged, the gunpowder and the primer combine to form a kind of a cloud, a gaseous cloud or residue. And then we can test an individual for this residue. So tests are done in the lab using what we call a scanning electron microscope. In the field, you can actually do what we call a gunshot residue test, and they come in little kits. And the way the kit works is on the back of these lids, it's like sticky tape. And you would put this on the person's hand and get some of that residue to stick, and then you'll put it in this thing and secure it, and then you'll put it in this gunshot residue kit, and then you can see again, it's called all the chain of evidence stuff, and these are the gloves, etc. And you would send this to the lab, and you would be able to determine whether or not somebody fired a firearm. So these are GSR kits, and you do these in the field. There is evidence as it relates to glass. Because there's different types of glass. So sometimes you may need to compare. We have high velocity glass versus low velocity impact glass. And there's actually a database when it comes to glass. So glass can have high evidentiary value. Tiny pieces of glass can adhere to a person's shoes or their clothing. And even larger glass fragments are processed for fingerprints. So we have to remember, if it's big enough, we might get a print on it. And they can actually be fit back together to indicate the direction from which the glass was broken. Was it broken from the outside in or the inside out? The same with soils. Forensic genealogists, they examine soils and minerals, substances like mud, cement, plaster, ceramics, and insulation found at crime scenes or on a victim or a suspect, on clothing or vehicles or other items. And this circumstantial evidence is important because it can place a suspect at a crime scene or basically kind of destroy their alibi. So again, you want to get as much of any type of evidence as you can. Even safe insulation or ropes, strings, and tapes. Laboratories have various comparison standards as it relates to ropes, strings, and tapes. And remember an important thing, fingerprints can occur on either side of a piece of tape, the sticky side and the non-sticky side. So it's always important to save the tape because you might be able to get a print. Just like plastic gloves, you're going to want to save those plastic gloves because when they take them off and throw the glove down, there might be a print on the inside of the glove. A lot of times you'll find evidence with drugs. So drug identification kits can be used at the scene to make a preliminary analysis of a suspicious substance. Now you're still going to have to send the full item to the lab to have a full analysis done, but you can actually do a test kit in the field. They look like this. And if you find some white powdery substance that you suspect to be cocaine, you open up this test kit, you drop a little bit inside, and there's an ampule. There's either 1 or 2 or 3. You can see the little ampules with liquid, and you pop 1 and then 2 and 3, or in some cases just 1. And if it turns whatever color, if it's orange, it's meth. If it's kind of a purple color here, it's codeine. Here it's opium. If it turns like a pink or blue in here, it's going to be cocaine. And then we have one for morphine. You have one for marijuana. You have one for almost everything. But these are preliminary tests or examinations that you can do in the field. Keep in mind some other types of evidence like laundry and dry cleaning marks. Many laundry services and dry cleaners use very specific marking systems. And you can actually submit your garment to a laboratory and they can look for impressions in the garment. Paints are complex, but they are also individual. And you can use small boxes for submitting, let's say, paint chips to the crime lab to compare it, let's say maybe in a hit and run accident or something like that. Digital evidence, of course, on cell phones. And there's a lot of different digital forensic courses that we can take, but being able to examine somebody's phone, now you're going to need a search warrant or consent, of course, to do that. But digital evidence is pervasive, meaning it's all over the place because of cell phones. Sometimes you're dealing with what we might call explosives or even weapons of mass destruction. These are things that are designed to produce substantial damage. A lot of times they're known as CBRNE. They call it CBRN. So, these are, again, things that you're going to have to kind of look at. Skeletal remains. That may be evidence that you recover at the scene. You're going to have to determine whether the remains are animal or human, and you may have to actually call somebody out, someone that deals in, let's say, forensic anthropology. If you find wood evidence, if it's found wet, keep it wet. If you found it dry, keep it dry. But again, you're going to have to figure out how to package all that. And there's a lot more detail on this in your book, but I wanted to make sure that we got through the whole thing. And then just consider, finally, some other types of evidence out there. So learn about what we call product DNA, like manufacturer codes on certain items. Discarded items like cigarettes, beverage containers, or receipts. These are all great items of evidence for various reasons. So, and then infectious disease. Be careful, and we're already in the COVID stage at the time of my lecture, so this is important. So at some point, you might be likely to encounter infectious bodily fluids. Make sure you use the universal precautions and consider all body secretions as a potential health hazard. Be consistently alert for sharp objects. Remember, don't stick your hand in someone's pants pocket so you get stuck by a needle. And after processing, make sure you decontaminate the crime scene and yourself. Make sure that you don't forget about yourself. All right, so in summary, criminal investigations rely heavily on various types of evidence. I think we've found that out. The more individual the evidence, the greater its value. Be cognizant and remember it's important on how you mark or identify each item of evidence, and make sure that you package evidence properly and individually. Make sure you document that chain of custody of the evidence at every stage. And after a case is finally closed, remember that there are specific ways, usually depending upon your department policy, on how evidence is returned to the owner, auctioned, or destroyed. So just a little over 60 minutes, not too bad. We did it in 2 lectures. I'm pretty happy about that. If I went a little quick, I'm really sorry, but I wanted to squeeze it all in there. But that's going to conclude part 2 of our Chapter 5 lecture covering forensics and physical evidence. Until next time.